more of the slope problems. Calculate the slope again from a couple of points. Let's take point 0, 0, and the second point 1 and 3. And we'll make this number 1 and this number 3. And the formula, again, to calculate the slope is the change in y over the change in x, or y from point 2 minus the y from point 1. That'll give us the change in y, divided by the x from point 2 minus the x from point 1. That'll give us the change of x. So for this particular problem, we said this was point 2 here. So this would be the y value, which is 3 minus 0, over a minus 1 minus 0. So the slope here is a minus 3 over 1, which you could write as just a minus 3, because whenever you have just a number, we automatically know that the denominator is 1. All right, let's look at a couple more of these here. How about point 5, 3 and minus 3, 1. Again, the slope is the change in y divided by the change in x. Which is going to be y2 minus y1 divided by x2 minus x1. So our y2 is 1, our y1 is 3, divided by our x2, which is a minus 3, minus our x1, which is 5. So this is a minus 1 minus 3 is a minus 2, and a minus 3 and a minus 5 is a minus 8. This is a minus 1 over a minus 4. Minus divided by a minus is a plus, so this equals 1/4. The slope here is 1 and 4. Now I'm going to graph these two slopes that I've just done so we can take a look and see what they look like. I'll draw them both on the same coordinate system for you. I'll draw my coordinate system. This will be my x, and this will be my y, and we don't know exactly where this line is, but we'll draw a line that has a slope of a minus 3. So we'll start the line right here at this point. We'll start both lines at that point. A minus 3 is the same as a minus 3 over 1, isn't it? So this is our change in y. This is our change in x. So if we were to draw this slope from this point here, our change in y, one of these has to be negative. It can either be a negative 3 over a positive 1 or a positive 3 over a negative 1. Let's do it both ways. A negative 3 over a positive 1. We're going a negative 3 direct in the y direction. Negative is down in y. So 1, 2, 3. All right? And a positive 1 would be over here. So here's the change in y, and the change of x can be represented by this line. Now let's go the other way and put the minus down in the denominator. So if we start at this point, we would go a positive 3 over a minus 1 will also give us a negative 3. So we go up 3. The change in y would be a positive 3. 1, 2, 3. And a negative 1 would be right there. Notice the slope is the same. We get the same line, the same slant to the line, and that's what the slope is. It's a measure of the pitch of the line or the steepness of the slant of the line. It's the same whether we go this way or whether we go this way. So that's a slope of a minus 3. Now let's see what a slope of 1 over 4 equals. This is the change in y over the change in x. So this could be either a 1 over 4, or it could be a negative 1 over a negative 4, because a negative 1 over a negative 4 is also a positive 1/4. When we divide negative by negative, we get a positive. So let's do this. We're going to go 1 in the y direction and 4, 1, 2, 3, 4, in the x direction. We'll start here again. We'll go a negative 1 down this way, negative 1, and a negative 4 would be a negative 1, 2, 3, 4. A slope of 1/4 looks like that. Notice the difference. First of all, this one's flatter. It's not as steep as this. 1/4 is, the smaller the y value with respect to the x value, the flatter the slope is going to be. But the important thing to see, observe in this, is the fact that when you have a negative slope, this negative 3 was a negative 3 over 1 or a positive 3 over 1, the line or the slope goes down as you go from left to right. As you go from left to right, the line goes down. For a positive slope, as you go from left to right, the line goes up, or it rises. If you have a rising line from left to right, you have a positive slope. If you have a falling line from left to right, you have a negative slope. Okay, that's the end of example 2, problem 2.